Hello, welcome back to AWS Solution Architect Associate. So this is Module 9 Guided Lab. So here we'll be creating a highly available environment. So let's learn about the lab overview and the objective. Critical business systems should be deployed as highly available applications. That is, applications remain operational even when some components fail. To achieve high availability in Amazon Web Services, we recommend that we should run the services across multiple availability zones. Many AWS services are inherently highly available, such as load balancer. Many AWS services can also be configured for high availability, such as deploying Amazon EC2 instance in multiple edges. So in this lab, we'll start with an application that runs on a single EC2 instance, and then we'll make the application highly available. So after completing this lab, we should be able to inspect a provided VPC, create an application load balancer, create an auto scaling group, and test the application for high availability. So at the end of this lab, the architecture should look something like this. We'll have a region. We'll be having inside that region, we'll be having multiple availability zone, and then we'll be having a VPC, and we'll be creating a public subnet in different edges, and also the private subnet in the different edges. In the VPC, we'll be having an ALB, application load balancer, which will be balancing the load, and also we'll be having an auto scaling group, which will auto scale and make the application highly available, and it will be powered by Amazon RDS database, and also it will be a multi availability zone standby. So let's start with task 1. For this, let's start the AWS account. So task 1, so we need to inspect the VPC, which is already created for us. So this lab begins with an environment that's already deployed via AWS CloudFormation. It includes a VPC, public and private subnet into availability zone, an internet gateway that is associated with the public subnet, a network address translation gateway in one of the public subnets, and Amazon relational database system instance in one of the private subnets. Currently, when we start our account, so the architecture looks something like this. We have a VPC, and then inside the VPC we are having two public subnets in different edges and two private subnets in different edges, and then we have a net gateway in one of the public subnet, and also RDS database. So let's open the Amazon Web Console and let's choose VPC. So let's go to VPC. Let's go to VPCs, and then we have this lab VPC created for us. So if you want to list only the resource inside this lab VPC, so I think the best option is to choose the lab VPC from this VPC, filter by VPC. So in the left navigation pane, under filter by VPC, choose select VPC box and select lab VPC. So I have already done this. So in the left navigation pane, choose your VPCs. So this is a VPC, which is my VPC. So in the detail tab, let's go to the detail tab. So this is a detail tab. So if we can see that we have this IPv4 CIDR block of 10.0.0.0 of 16, which means that VPC includes all IP address that starts with 10.0 and XX. Okay, so we can have an IP of 10.1.32, something like that. Okay, so let's go to subnets. So I'll open a new tab so that it will be easier to route around. Or as we have used the filter, so I think let's go just filter this way. So these are all the subnets that is available inside this VPC. We have two public subnets and we have two private subnets, and then they are across different availability zones. If you can see, so we have public and private subnet in this availability zone 1A, and private and public subnet in this availability zone 1B. Okay, so we have seen like where it's decorated. So let's choose. So we can analyze this, the CIDR block, the available IP addresses, and the available zones and all. So this is it from this. So like if you want to see more detail on this public subnet, then we have more details here. So number of addresses here, and then the route table is being associated to, and the network ACL it's been associated to. Okay, so here we can go to route table, and we can see that this public subnet 2 is have two route. If we see this route table association, so we have two routes. Okay, So one is all the VPC traffic are sent to the local, and all the outbound access are given to the internet gateway. So this way, this is a public subnet. Okay. Okay. So let's go to network SCL tab. So we have this network SCL. Let's choose this. And it's being associated with 4 subnets. So basically it's private subnet, public subnet, private subnet, and then a public subnet. So this tab has information about the network control list. It's associated with the subnet. So the rules are currently set to the default setting. They permit all traffic to flow in and out of the subnet. So if we see the inbound rule, so it allows all the inbound rule. It allow, and here it allow all the outbound rule. Okay. So let's go to the internet gateway. So we have this internet gateway. So it's being attached to the VPC. The lab VPC. So let's go to route security groups. So these are all the security groups which we have. So if I choose the DB and go to inbound rules, you can see that we have this access to the incoming traffic to this DB. So you can see that the rule defined in the security group permits inbound MySQL or Aurora traffic 3306 from anywhere in the VPC. Okay. And then if we go to the outbound rule, so however these settings can be modified as needed. Okay. So now let's start with the task 2, creating an application load balancer. So to build a highly available application, so it is best practice to launch resources in multiple AZ zones. Availability zones are physically separate data centers in the same region. So if we run an application across multiple availability zone, so we can provide a greater availability if the data center experience a failure. So it means that if one of the availability zone is down, so we can make sure that the availability zone from the other, the resources from the other availability zone will work as expected. Okay. So let's go to services and let's go to EC2. And let's go to load balancers. So we don't have any load balancer yet, so we'll be creating a load balancer. Okay. So let's choose create load balancer. And here we'll be using like the application load balancer. And let's say create. And let's name as what we have here, inventory LB. It will be internet facing. And then let's go to network mapping and let's choose lab VPC. And then let's add this into and select. So you will now specify which subnet load. Under mapping, first choose the first availability zone, then choose the public subnet that displays. So let's choose this and let's choose public subnet. So let's choose this and let's choose public subnet. So we have chosen both of them, and let's continue to the security group. So we need to go and select a new security group. So it seems like we cannot create a security group from here. So let's go to security group. Okay. So let's create a new security group. Create a security group. And let's say inventory LB. Description should be, we'll use the same whatever it's mentioned here. We'll remove this and we'll add lab VPC. So we'll say HTTP add rule HTTP anywhere, and then let's add rule again and let's do HTTPS. And let's say anywhere IPv4, and then let's say create security group. So we've created security group. So now I can go and use the security group. So we should have the inventory LV, and let's remove this default, and we'll have this listeners and routing. So in the listener and routing section, choose create target group. So we'll go to create target group, and then a new browser tab is open. So choose a target type instances. So let me close this. So it should be instances, and target group name should be inventory app. So VPC should be lab VPC, and advanced health check section. And healthy threshold should be 2. Interval 10 seconds. So this means that it will check for the health for every 10 seconds, after every 10 seconds. So will result in health check being performed every 10 seconds. If the instance respond correctly twice in a row, it will be considered healthy. So that means it will go for a health check, and if it got twice, then the instance will be remain as healthy. And let's go to next. So let's skip, and let's say create target group. So we have created a target group. So targets are individual instances that will respond to a request from the load balancer. So we don't have any application instances yet, so we can skip this step, and let's create a group. So let's go to this load balancer, and let's refresh and choose the inventory app target group. And let's scroll down to the bottom, and let's say create load balancer. Choose view load balancer. So we have a load balancer created now. So a target group is associated with the load balancer. So now we need to create an auto scaling group. Amazon EC2 auto scaling group is a service designed to launch or terminate Amazon EC2 instance automatically based on user defined policies. So based on the auto scaling, like it will choose like if we have to terminate an instance or launch an instance or create a resource, something like that, so that it will make the application highly available across multiple availability zones. So let's create an AMI for auto scaling. So in this task, we'll be creating an AMI first. We'll be creating an AMI from the existing web server 1. So this will save the contents from root volume of the web server so that a new instance can be launched with an identical configured guest operating system. So let's go to EC2 again. So we're in EC2. And let's go to choose instances. Let's go to instances. And we have this web server 1. Let's choose this. Let's go to actions, image and template, and let's go to create image. So the image name should be web server AMI. So let's close this target group also. So description should be lab AMI web server. And let's create an image. So why are we creating this Amazon machine image AMI? Because when the auto scaling group launch any instance, so we want that instance to be in the same state of the other instances, right? So for this, we make sure that all the required resources are already in the instance, in that image, in the base image. So based on that, all the newly created instances from the scaling group, it will have the same state. Okay, so we can copy this AMI ID. So I've copied the AMI ID, so we may need later on. So now we need to create a launch template. So what's a launch template? So launch template is something that auto scaling group will be using to launch an instance. So like you should know which type of template I'm using to launch the instance. Okay, so let's go to launch template. So we have the launch templates here. Let's create launch template and let's follow along. So the name should be inventory LT. Under auto scaling guidance, select provide guidance to help me set up a template. So let's choose this. So my AMI owned by me, so this should be the AMI. T2 micro, so I need to choose the keypad as VOC key, and also I need to choose select existing security group, and then here I need to use the inventory app because I want to have the same security group for each instances. Inventory app, let's go to advanced details, and let's go to inventory. Let's in the IAM instance profile, let's choose inventory apparel. Inventory apparel, detail cloud monitoring, so I need to enable this. So this will allow auto scaling group to react quickly by changing utilization. So under user data, let's copy and paste all this thing. So this is the user data, and let's say create launch template. So we have created a launch template. So now from this action page, I can say create auto scaling group, inventory ASG, inventory LT. Let's go to next. So we need to choose lab VPC. So we need to choose private subnet 1 and then choose private subnet 2. So we need to choose private subnet 1 and then we need to choose private subnet 2. Correct? This will launch EC2 instances in private subnet across both available zone, and we need to choose next. So here in the load balancing panel, choose attach to an existing load balancer. So this is the inventory app. In the health check panel, health check grace period 90 seconds. Let's go to health check grace period 90 seconds. So in the additional setting, so we have this monitoring. So here we need to select enable group metrics collection with CloudWatch. So I've enabled, and then let's choose next. So now we need to choose the desired and minimum and maximum capacity. So this is a group size, so let's choose 2, minimum 2, maximum 2. So this means that the minimum number of instances that should be running should be 2, and also we are saying the maximum number of instances that should be running 2, and the desired capacity should be in between this minimum and the maximum capacity. So like this will allow auto scaling to automatically add remove instances, always keeping between 2 and 6 instances running. So it should be here 2, so it says 2 and 6 instances, but it should not be between, it should be like it will always keep 2 running. So under scaling policies, like it's already none, and then let's go to next. And in the step 5 we don't have any notification, so we can choose next. And if we want, we can add tag here. Let's add the tag. Key should be name, and the value should be inventory app. inventory app, and next. So let's review this, and everything looks good, and let's create an auto scaling group. This we should have this auto scaling group created for us. So let's review all this by clicking auto scaling group. So you can see that we have a desired capacity of 2, minimum capacity of 2, maximum capacity of 2, and then it has a launch template of inventory launch template, and it's attached to the security group, and it will be created under these available zones in that lab VPC. So we have this load balancer, and everything looks good. So when we provide these minimum and maximum instances, like value, we have provided 2 instances. So this will make sure that the Amazon EC2 auto scaling will try to always provide 2 instances even if the failures occur. So if you remember, we haven't created any instances yet, but if I go and refresh here, because of the auto scaling group, like it checks the health, it didn't find any instances, and it goes and create these 2 new instances for us. So these 2 instances were created by the auto scaling group. So it says after a minute, choose the refresh icon to update the display. It should show that 2 instances are running. So currently they are running, like, right? So let's continue. So now we need to update the security group. Okay. So we have load balancer security group. So we already configured the load balancer security group. When we created the load balancer, it accepts all incoming HTTP and HTTPS traffic. So the load balancers have been configured to forward incoming requests to a target group. So when autoscaling launches new instance, it will automatically add those instances to the target group. So now let's go to application security group. So the application security group was provided as part of the lab setup. So we will now need to configure it only to accept incoming traffic from the load balancer. So let's go to security groups. And let's select inventory app. So let me close this. I'll choose inventory app. So we need to go to inbound rules. So we don't have any inbound rules yet, right? So the security group is currently empty. We need to add a rule to accept incoming HTTP traffic from the load balancer. And we do not need to configure HTTPS because the load balancer was configured to forward HTTPS request by HTTP. Okay. So let's choose edit inbound rule here. Let's add rule. The first type of should be HTTP, and it should be custom, and it should be from the load balancer. SG. So I need to choose the inventory LB. So let's say traffic from the load balancer. So this inventory app security group is basically, it will forward the HTTP request to the load balancer. So the application serves now receive traffic from the load balancer. This includes health check that the load balancer performs automatically. So now we need to set up the database security group. So let's configure the database security group to only accept incoming traffic from the application server. So let's go to security groups and let's choose inventory DB. So this is inventory DB. So if we see the inbound rule, we have a MySQL Aurora request that should be in the port of 3306. It's been sourced at this 10.00.16. Okay. So the existing rule permits traffic from 3306 from any IP addresses within the VPC. So this is a good rule because security can be restricted further, right? So let's go to inbound rule. Okay. So now I can, like, it asks me to delete this, and let's add rule. And here I can say MySQL Aurora. Say SG security group should be as inventory app security group, and let's add the description if it's there. traffic from the application server. So here any traffic from the application server, we are giving the inbound rule for this security group. So let's follow along. So we now have configured 3-tier security. So each element in the tier only accept traffic from the tier above. So in addition, the use of private subnet means that you have 2 security barriers between the internet and your application resources, right? So now let's test the application. So our application is now ready for testing. So like we'll confirm that our web application is running. So we will also test that it is highly available. So let's go to target group. So we have the target group here, and let's choose inventory app. So it is currently healthy, and it says 2, that means for the 2 instances. Okay, so we will test the application by connecting to the load balancer, which will then send our request to the EC2 instances. So we first need to retrieve the DNS name of the load balancer. So let's go to load balancer. Let's choose this load balancer. So we have this DNS. Okay, so let's open the DNS in the new tab. So basically we have this page open, right? So here when I open this URL, the load balancer forwarded the request to one of the EC2 instances. The instance ID and available zones are shown at the bottom of the web page. So if you see, so we have this instance ID here. So earlier, as we say, we have multiple instances, 2 instances. So let's say it's 81. So when I requested this endpoint, so the load balancer route the request to this application. So let's refresh again. So at that time it was 81, now it's 32. So that means we are getting the response from this load balancer, from this instance, from this inventory app. When we reload the page, we notice that the instance ID and available zone sometimes toggles between the 2 instances. So when this application displays the flow of data in the network is, so we connect it to the internet, it goes to the application load balancer, and then it routes to the application server. So when we send the request to the load balancer, which resides in the public subnet that are connected to the internet, the load balancer chooses one of the EC2 instances that reside in the private subnet and forward the request to it. So the EC2 instance then return the web page content to the load balancer, which return it to the web browser. So now let's test the high availability. Let's go to instances. So we have these instances open, and let's choose one of the inventory app. Let's say I want to choose this, and now let's terminate it. That means, let's refresh this. The health check should be all passed. Okay, so let's choose this and let's terminate. So that means when I terminate the instance, what will happen is the application, the auto scaling group would not receive any health information from this instance. Thereby it will go and create a new instance, because we have the desired instance count of 2, right? So the status check, health check is now nothing, because we are starting down. So if we refresh, now you see that a new instance is starting to create. So why this happened? Because the auto scaling group, so they didn't get any health check from this instance. It shows that the instance is down. Thereby it goes and create a new instance here. So you should notice that available zone that is shown in the bottom of the page stays the same. So now if I refresh this multiple times, now the instance ID doesn't change like earlier, because currently we have only one instance running. So that's why the instance ID here doesn't change. Okay, so after a few minutes, Amazon EC2 auto scaling will notice the instance failure. It was configured to keep 2 instances running. So Amazon EC2 auto scaling will automatically launch a replacement instance, so which I just showed you here. Okay, so let's wait until this status check is 2 out of 2, and then we'll refresh the browser again, then it should interchange between the new instance and the existing instance. So you see, so now it routes to the new instance, which is instance ID of 67. So this is a new instance. So we have this optional task 1, making the database highly available. So until now we have made our application highly available, but we also want to make our database highly available. So to do that, let's go to RDS. And let's choose databases. So we have this inventory DB already here. And let's choose this inventory DB. Let's say modify. So we need to go to availability and durability section. Storage. So here is availability and durability section. So here we need to select for multiple Azure deployment, select create a standby instance. So we'll select this. So what we'll do is, so we only need to configure this one setting to convert this database to run across multiple data center. So this option does not mean that the database is distributed across multiple instances. Instead, one instance is the primary instance, which handles all requests. Another instance will be launched as a standby instance, which takes over if the primary instance fails. So our application continues to use the same DNS name of the database. However, the connection will automatically redirect to the currently active database server. So we can also scale an EC2 instance by changing attributes, and we can also scale the RDS database this way. Now scale up the database, and let's scroll up to the instances. So now I can change this from dbt3 micro to dbt3 small. Let's choose dbt3 small. Okay, so this action doubles the size of the instance. So for allocate the storage, enter 10. So let's say 10. So it should be 10 GB, and let's go to continue, and let's apply immediately. So this way we have made our inventory DB highly available. Okay, so let's go to optional task 2, configuring a highly available net gateway. So the application server runs in a private subnet. If the server must access the internet, for example, to download data, the request must be redirected through the network net gateway. So that means, like, let's say we have so many instances private inside the private subnet. So if they want to access the internet, they have to go through, the traffic has to go through the net gateway, right? So in order to handle that, so in the current architecture we have only one net gateway. Thus, if the average zone 1 fails, so the application server will not be able to communicate with the internet. So that means we have a net gateway here. So if this fails, that means we don't have connection, internet connection, right? So for this, if we have net gateway in multiple subnets, so this way we can, like, in multiple availability zones, so we can make sure that we don't have any failure of as such. So let's go to VPC. And let's go to net gateway. So let's create a net gateway. So let's choose private subnet, public subnet 2, public subnet 2. So choose allocate elastic IP. Okay, and let's say create net gateway. So after that we'll create a route table. Let's go to route table, and let's create a route table by this name. Let's go to create route table. Let's choose this name. Let's choose lab VPC, and let's create a route table. And let's go to the route tab. So we have all the traffic from this are passed sent to the VPC. Okay, so only one route, all traffic locally. So we now add a route to send inbound traffic through the new net gateway. So let's choose add route and edit route tables, add route, and let's choose the destination as this one, and let's choose net gateway. So we have couple of net gateway here. So I think from here, let's say show. So net gateway is F2, so we need to choose the other one, 8SC. Let's close this. And let's say it's save changes. So now we need to choose a subnet association. Subnet association. Edit subnet association. And I need to add this in the private subnet too. Private subnet too. So this action now sends internet bound traffic from private subnet 2 to the net gateway that it is in the same availability zone. So now our net gateway are also highly available. A failure in one availability zone will not impact traffic in the other availability zone. So let's refresh once again. It should still work. Nice. Let's submit. So I think this is it from this module 9 guided lab. So now we are able to fulfill all this thing. Like we were able to inspect the VPC. We were able to create an application load balancer. We were able to create an auto scaling group, and we were able to test the application for high availability. And also we have made our DB RDS database highly available. And also we created another net gateway and added to the other availability zone so that we have no point of failure. So this way we have made our application a very highly available environment. So we have scored 75 out of 75 here. So this is from this lab, and then see you in another lab.